we're going to be looking at volume. Now, what is volume? Volume is the amount of 3D space an object takes up, or you can think of it as like the amount of space inside the shape, so within the shape. It is measured in cubic units. So when you talk about centimeters cubed, you're talking about a little cube with 1 centimeter sides. And it's how many of those, 1 centimeter is all of those, and the volume of that is 1 centimeter cubed. You're talking about how many of those little cubes could fit inside this shape. We've got some learning goals, success criteria here, talking about the difference between prisms and pyramids, the rules that we use for volume, and we'll look at some simple and some complex examples in this video. Our basic rule for the volume of prisms is it's the area of the base times the height. Now we'll get a little bit more into detail of that. So a prism, first of all, is a shape which has a cross-sectional face which travels back through space and is the same like at the other side. Okay, you can see a cylinder acts like a prism. It has a circle, and then that travels back through space like perpendicular to that face, travels back through to create the shape. That's the way you can picture it. So a pyramid does not do that. A pyramid has a type of a base, and then as it goes back through space, it gets smaller, okay, to end up in a point. Okay, a sphere, so a ball, is another example that is not a prism. It doesn't have a cross-sectional face. All right, let's use our volume of prisms formula in some examples. It is really important that the base is our cross-sectional face. Look at our examples just here and figure out which face is the cross-sectional face. And it's important that the height is perpendicular to the base. Now the base won't always be at the bottom of the shape, okay, it's just a cross-sectional face. So in a rectangular prism, you can choose any of the faces to be your base or your cross-sectional face because they all fit the pattern of being able to go back through space to create the shape. So when we're doing this, you pick one. We've picked the front one here. So volume is area of the base times the height. Area of our front face here that we've called the base is 6 by 4, and the height is how far back through space it goes, so it's that 5. Okay, you may also notice that this looks like the length times the width times the height, and that's the formula that we have for rectangular prisms because the area of the face is like the length times the width. Anyway, this ends up being 120, and our units are meters cubed. Remember, cubed units. Cylinders, as I said, are not prisms, but they act the same way for the purposes of volume. So we're looking again for our cross-sectional face, which is the circle. It's going to be the area of that multiplied by the height, as in how far back through space that circle goes. The area of our circle is pi r squared, so that's pi times 2 squared, and the height is 6. So that makes 75.4 centimeters cubed. Now, this shape here also acts like a prism. It has a cross-sectional face. It's like a kidney bean kind of shape. It goes back through space and is still a kidney bean shape, the same size on the other end. So this acts like a prism. And although this looks a bit weird and different to the others, this is actually easier to calculate because they're telling us what the area is. When you get a shape like this, you'll just be told what the area is. So that's 5, and then how far back through space it goes is 2. 5 by 2 is 10 centimeters cubed for our volume. You'll notice in terms of our units, the area was centimeters squared, of course. So we had a centimeters squared times centimeters, which makes centimeters cubed. All right, our last ones are pyramid and cone. So the formula that we use for these shapes is a third of the prism that would contain them. So you can see this area of the base times the height. That's if it was like a square-based pyramid, sorry, a square prism. And the pyramid only takes up a third of the volume of that prism. The proof for this is calculus, so it's like year 12 level methods or specialists to do this proof. There are examples where you can show that it takes up that much by having like a pyramid-shaped container and a square prism container, and you can show how many pyramids it takes to fill it, etc. Anyway, you can look those up if you would like, but that's the formula. That's why you can fit 3 of these inside a box. Alrighty, so we are again just subbing into a formula. A third times area of the base, this is 5 by 5, so that's 5 squared, times the height, which is 10, which works out to be 83.33 meters cubed to 2 decimal places. The cone working is here as well. You can see we've got a third times the area of our base, which is a circle, multiplied by the height there. Alright, here are a couple more complex examples. Ignore those are from last year. Have a look at these 2 questions. Just pause and see how you would figure them out, and we'll just talk through the solution. Alright, so for these, you can see that the volume of this whole shape is going to be made up of the volume of the large one plus the volume of the small one. Okay, so we've got our 2 volumes being figured out here, and then to figure out the total, we're just adding them together. For the second one here, this looks like a pyramid. Okay, it looks like a triangular-based pyramid, and it has an equilateral triangle base. So remembering our formula, we need to know the area of the base. We know the height is telling us that's 10. We need to know the area of the base. We need to do, let's see, does it tell us? It does. Look, it tells us that it's 3.64 centimeters is that perpendicular height of your base triangle. If you weren't told that, you can figure it out. If this is your base triangle, 4.2 centimeters, you can create 2 identical right-angled triangles by doing this. And then if you just take one of them, this side is 4.2, like it was before. This is your perpendicular height you're trying to find, and you've taken half of the base, so that's going to be 2.1. And you can do some Pythagoras to find h. So that's a much more complex problem, okay? But you have all the skills to be able to do it. So that's how you would then find the h, which you already have, multiply, etc. So just to recap that, we looked at volume, which is measured in cubic units. We looked at the basic volume for a prism formula. We did some examples. And we looked at the volume of pyramids and cones, which are a third of the prism or cylinder that contains them. And we looked at how you would approach some more complex examples.